Hi, I'm Ned and I make games. This video is from my live stream over on twitch.tv/NedMakesGames, where I'm live Monday, Wednesday, and Friday at 9 p.m. US Eastern Time. I'd love to see you there. Alright, hey everybody. How have you... Well, actually it hasn't really been that long since I saw you last. I was just live last night, but I hope your day was pretty good. Alright, so last time we were working on a Mario Party. Well, there's a not really a competition, I guess a collaboration between a bunch of game dev YouTube channels where we're going to try to remake all the mini games in the first Mario Party. So I was assigned the game Bash and Cash, which I guess I can show real quick. It's going to pop up in the wrong window, but so we're going to try to remake it in Unity, and probably just to make things a little more fun, I'll also add a little bit of my own spin on it once it's all done. Oh, so you can watch an ad. So yeah, anyway, so this is it. It's basically one character runs around and the other three try to hit him with little hammers. And I couldn't find footage that I could use on stream, but usually little money bags would fall out of him when you hit him with a hammer and kind of like move across the game area, and the other players would try to pick them up. So first thing I want to do is finish up the character controller. Hey NTT, how are you doing tonight? And we found out, well, actually I think it was NTT that saw that my code, there was an issue with my code, and basically I think it comes down to I'm letting the controller get too close to the wall, and so the raycast clips through it due to a floating point rounding or whatever reason. So I think that comes from right here, where I try to clip the move based on this distance. So I need to add like a, I don't know, like another I'm trying to say, I need to add like a minimum distance from the wall. They should drop the Ned Makes Games logo when you hit them with a hammer. That'd be kind of funny. But yeah, probably will do. Maybe do something like that. I haven't really decided. I'm pretty sure that the money bags is where, I know, what would be something on my channel without some kind of fancy visual effect. So I'm sure we'll try to make some special sparkly coin shader. But anyway, so I need to have like a minimum distance that you can get to the wall. So I'm trying to just think about the best way to do that. Okay, so this distance is from the ray's origin to the impact point. So instead of clipping there, I should subtract a little bit from here. Let's just hard code something at first. And see if that fixes it. Oh. Oh, it's a double. Okay, it does fix it, but now it's kind of bouncing back and forth. So we'll want to try to prevent that. Well, at least we found the reason that it was passing through walls. So now we can try to clean this up. I think actually the easiest way to do it, I'll do this with, if I was doing it with a ray cast. I don't know if it'll work as well with a capsule cast, but usually I would like inset the start position of the ray cast, a very small number. So that way, even if I am directly touching the wall, it won't, like it will still see it because the capsule's moved backwards a little bit. I think it'll be fine unless the characters get like wedged between two walls, then maybe something weird could happen. But I don't know. I don't think that will happen in this game. I don't know. I'll have to see. I guess if... I'm just thinking like if you get right next to the wall, okay, well, I don't have to worry about it unless it actually happens, but I was thinking that maybe if you get right next to the wall and try to move away from it, if I offset the collider, then maybe it would like clip into the wall and not let you move away. But let's just try it out. What do I want to call this? Actually, I think I'll just make it realize field, a field here, so that I don't have to pass it in every time. I guess let's just call it so. Basically, we're going to start the raycast not directly in the center of the object. We'll actually offset by this distance and the negative of the check direction. Yeah, it's just confused about vector 3s and float 3s again. Okay, and then in here, yeah, we can take away this. So I'm hoping that this will let us be able to move right up next to the wall, but not go through it. Okay, no. Oh, well, the offset's still 0. So make it, I'm going to try, well, we'll try a large value at first. Oh, we also need to add since we're starting backwards, we need to add this value to the length to get the original raycast length. Let's see. Float effective length equals the length plus the offset. And then I'll pass that. Right there. Okay, no. Let's... Okay. I was just gonna see if I could kind of tell what's happening. Let's make I'll make this length a little bit larger. Okay, no, it still doesn't work. Although, seems like it's not working correctly because the offset's supposed to be the opposite direction. I'm passing that through. I feel like, yeah, see, it's because this debug is really, like, the line is far ahead of the character. It should be behind the character. I would think, anyway. Because I'm subtracting. Okay. Yeah, I don't really want to, like, clamp the character like a certain distance from the wall, because then if they got pushed into the wall for whatever reason, then they would just be able to walk through it. So we kind of need to find some way that if it's right up against the wall, they'll still collide, which is what I'm trying to figure out. And I'm surprised this isn't working. It seems to work consistently if it's normal to the wall. Oh, okay, maybe not. I was gonna say, because that way it just goes through it. All right, so okay, let's. I wanna. Okay, let's change this just to do a ray cast and see if it works that way. Because yeah, I don't really know if my issue is with the capsule cast or if it's something that I'm doing wrong, because I haven't really done capsule casting before. Let me see. Center point. Yeah, we don't need that. We need the direction. The effective length. Okay, and then F physics. Okay, so this is actually going to cast from the center of the object, which isn't right. So we need to add the radius of the capsule to this. What's it complaining about? Oh, this is a foot 3. Hey, Gowie. Pretty good. Just working more on the Mario Party minigame. Trying to figure out some of this ray casting stuff. Oh, right. I'm trying not to do capsule cast. So start point, direction. There's like, well, 16 overloads here, so I'm hoping remembering the correct order here. Length, mass. Okay, and then I need to get the hit info. Okay, so the hit info goes here. It goes right after the ray, so maybe it goes right after the position and direction. Let's hope. Oh, sorry, I don't know if I asked. How are you doing tonight, Gowie? Okay, there we go. Oh, I don't need that far. Okay, so I'm gonna see if it will work with just a single raycast. This won't be, we can't use this for the full game because otherwise people could walk through, or we could walk through the side, but pretty good. You had a walk with a friend of mine I hadn't seen in a long time. Oh, that's always nice to catch up. Okay. Well, it kind of works, although it goes a little too far. Oh, what's going on? It seems like if you hold the right mouse button and then use certain keys on your editor, it does something with the orthographic view. Okay, but it's still not, okay, it's still not perfect, so maybe it's something with my logic and not the capsule collided. Or the capsule cast. Because that way it works, but when I try to do it there, it doesn't. It'll let me walk through this side. Okay. But again, like when I increase the offset length, it doesn't seem like it's offsetting in the correct direction. Because like, yeah, because it goes out ahead of the character when it should go behind the character. I wonder, is the direction normalized? Maybe that's part of the problem. Oh yeah, because we take the length here and then we divide it, so that's the same as normalizing it. Excuse me. Okay, we can see that it does. Yeah, the raycast does start like entirely behind the character. It seems like it's something to do with this hit info distance. Oh, you know, okay, I think what might be happening now is that when I offset, this hit info is not being or we're not removing the extra distance from the offset. How do I want to handle that? Because I don't really want the character engine to have to worry about that kind of thing. Maybe we should just not return this hit info and we'll return our own structure. Yeah. I'm used to working with fraction because that's the how it is in the 2D collider, so I think I'll just use that here. So what we would do, okay, so we got to return a character hit info. And we can't name it the same actually because we have to use the Unity's hit info here. Okay, so the character hit info dot fraction will be, so we use the Unity hit info distance subtracted by the offset length, and then we divide that by the length passed in. Okay, and then this will just be technically, yeah, we got to make this a little bit more complicated, but I don't know. I'm used to working with fractions, so so hopefully this will maybe fix. Okay, so now it's, yeah, we're colliding sort of. But yeah, it doesn't always work because it's still letting us get through the wall, but kind of like pushing us back. I wonder if it if this happens every frame, or if something like triggers it every couple frames when we move a certain distance into the wall. Let's see what this gives us. All right. So yeah, so it is a few frames apart, which kind of goes with what I saw because it's like jumping back randomly. And the fraction, okay, this is also strange because the fraction is negative. Um, and also very large. It should never get larger than 1. Um, oh, well, okay, so here I'm raycasting using the passed in length and not this effective length, so that might have something to do with it. Okay, well there we go, it's not jumping. And it seems like... Okay, so we do collide, well, technically not every frame, but it's not jumping. Oh, I think that was just me taking my finger off of it, but here we're colliding every frame, and then the fraction is basically 0. So I wonder... Yeah, if I keep on moving into the wall, will I eventually get through it? Okay, doesn't look like it. Well, yeah, when I move... I'm not sure if I'm actually moving into... Oh, so I am moving into it a little bit when I move diagonally. But it doesn't seem to let me go through it. Okay, well there's worse bugs. Okay, so it seems like, yeah, when I move straight into the wall, oh, I was gonna say it's always 0, but not quite. And then when I move diagonally into the wall, it lets me... Oh, well that's probably just because the raycast doesn't cast for the entire capsule, it's just in the center. So that's probably not a big deal. So can I just take this code and change it into the capsule cast and see if it works then? So basically what we've done... Okay, so we've got center point, direction, the effective length. So I guess the magic was just using this computed fraction. Okay, so hopefully this will work with the entire capsule cast. If it doesn't, I might just roll my own capsule cast using a bunch of different ray casts. Okay, but yeah, it seems like it's fine. And we don't have that... Oh, well there I just got through. Okay, but I'm trying all different directions here and it's not letting me through. But a second ago somehow I got through the corner. Okay, now I'm not able to reproduce it though. Okay, well, I'm sure if anybody ever tries to speedrun this game, they'll be able to get through there somehow, but I can't reproduce that bug, so I'm not going to worry about it too much. It has to do with there being this like single corner here, so if I just increase the size of these slightly, I'll probably get rid of that problem. We'll make a prettier arena eventually. Alright. So yeah, we finally figured out that. Let me think. I'm still curious about why the debug line doesn't match, but yeah, it doesn't ever offset by the cast length. I don't know, but I mean, as long as it works. I mean, I'd like to debug to match up, but I guess I don't want to spend too much time on it. Okay, so yeah, right now, if there was another wall, there were, like, if I had something like this, I think, things would get a little weird because the debug or the offset would, like, clip through this wall. Actually, it still works pretty fine. Well, that's good to see, I guess. What just happened there? Oh yeah, you can like sidestep around corners, but anyway, so probably we don't need to have such a big offset length, I don't think. So I'll shorten it and that will make the raycast quicker. And it seems like we still can't get through the walls, so. Okay, so the only thing I want to try now is that if I'm moving like backwards in the space, right now when I hit a wall, I just stop. Where actually it would probably be better if I just moved like against the wall in this direction. So we can try to figure that out. by getting the normal vector of our collision. And then we can like cross product the movement direction with the normal vector, and then that should give us like a slide direction that we can move. Doing that will also, we'll need to do another collision check in that direction. But probably at that point, if we collide again, we just will stop movement and not try to slide anymore. So I think the Unity hit info will give us the normal vector. Okay, so here, okay. Yeah, that's fine. So I guess like the movement that's not truncated by this fraction, we would want to try to move on the normal vector. So do we have... Okay, no, we don't have a project. Because I thought that maybe I could just project the rest of the movement onto the cross product. Okay, I'm just thinking now. Let's see what happens. I think I also want to stay on the same like plane, so I also probably need to project against the up, or take the cross product against the up vector as well to make sure it's perpendicular. So you're back, okay. Sorry about that, I don't know. My internet just decided to crash for a second. But anyway, so yeah, I was going to try to project onto the cross product vector. You might not need to do that really, but probably be the easiest way to handle it. I'm still, Twitch is giving my stream report and I'm not done yet. But anyway, okay, so first let's find the reflect vector. I don't know, I guess slide vector would make more sense. So, okay, so we cross product with the movement direction and the normal direction. Move direction and hit info dot normal. Oh, hi Daltorio, how are you doing today? All right, and then I also want to take the cross product with the up vector so that we don't move in another plane. Because I think, yeah, if these aren't, the move direction and the normal probably won't be orthogonal, so they technically there's infinite cross product. You're good, and I'm doing pretty good tonight too. Oh, it's all right, no problem. Just trying to figure out some physics here. Yeah, it's been a long week, so do excuse if I make some math mistakes, but we'll figure it out. So yeah, I want to take the cross product again with this and the up vector. Yeah, so like I was saying, so it'll stay perpendicular. You're a baguette. Oh, I do know a little French, but it's been a few years since I've actually used it, so I'm probably extremely rusty. Okay, and I guess should normalize this maybe. Okay, and then I want to project the basically the slide movement onto this vector. So displacement, rest of movement. It will be, so the move direction times the move length times 1 minus the hit info fraction. And then, okay, so there's no project function. I don't remember it off the top of my head, so let's ask Google. Vector project formula. I know it's basically, it's like the dot product of 1 over, oh yeah, so it's a dot b over the squared length of b times b. So if you want to project a onto b, so, and again, when you project, that's when you like take one vector and only take the component of it that's parallel to the second vector. It's more simple to learn English in a game, movie, or series and more. But you can't really write understandable long text. Yeah, I know what you mean. Yeah, I took a few years of French in school, and I was better actually at writing it, because I never really used it in conversation. But yeah, I should watch, to keep it up. I should watch more French stuff, and then I would get the other side of it. Okay, so let's make our own little math helper class. I have a feeling I'll need one anyway. And I'll just add the project formula to that. NMG math is fine, I guess. Okay, and then we'll have public static float3 project. Okay, so what was it? It was like a dot b over the squared length of b times b. So we'll return b times dot a b divided by, yeah, if you take the dot product of a vector with itself, it's its squared length. So in that case, do I need to normalize? Yeah, I guess I don't need to normalize the slide vector, because the projection will take that into account. French is really hard to write. Same for people that live in France. We are terribly bad at writing in French. Yeah. Well, one thing that was hard for me when I was learning it was that, you know, a lot of things are not spelled how they look, but I guess English isn't that much difference in that, or that much different in that respect. Okay. Yeah, so now I need to project. So the rest of the movement onto the slide direction. All right, and now I need to do another check collide with this. Maybe I should do a helper function. Okay, well, we already kind of know the length. So float slide length equals this. Although, wait, we have to calculate it again after projecting. What am I trying to code for now? I'm trying to recreate a Mario Party minigame. Mostly I'm working on the character movement at the moment. Your father's from England and your mother is from France, so you had it easy being bilingual. That is, yeah, they say it's a lot easier to learn things when you're young, or learn languages anyway. Yeah, pretty much all my family just speaks English, so I've had to try to teach or learn myself in school. Okay, so basically I just want to repeat this, but we'll clean it up later. So float, slide length equals the rest of movement divided by, oh no, I guess it's just the length of this vector. Okay, and then the direction we already know. So I guess I do need to normalize this after all. So, okay, there's probably some way to make this more efficient, but it's fine. Okay, so if collider, check collide, slide direction, slide length, and the same mask. Again, I guess we don't really care about the hit info in this case, but okay, so if we collide again, we'll just clip the displacement. Your parents tried to teach you English when you were very young. Oh, your school said no, you have to learn German. It's alright, I understand. Oh, so are you trilingual then? Oops. So, what do I want to do? I guess I can just add on the slide thing. Okay, I guess I do need the fraction after all. So we add this onto the displacement. Okay, so let's see. Hopefully this math is right. Okay, so no. So what should happen is right now I'm moving to the right, so when I slide I should slide along the wall. Well, that's what I'm going for anyway, but it doesn't seem like, or I got the math wrong somewhere. It's terribly late, you need to wake up in 4. Yeah, I was thinking that it is pretty late in Europe, but thanks for coming by, Del Torio, and chatting for a bit. And thank you for following, I appreciate it. I hope you have a good night. Alright, so let me... How do I want to do this? Let's debug the slide direction maybe and see if it makes sense. Thanks, Del Torio. Alright, so I mostly want to make sure this vector... Okay, so right now I'm pressing right. And so the input, it's kind of confusing because it's in, what's the term? It's isometric. So it's giving me negative 0.7, negative 0.7, and this is this positive 0.7, so it's telling me to go backwards. Okay, well that's interesting. That's not what I was expecting. Oh, you know what? Maybe I don't want to take the cross product with the movement direction and the hit normal. I just want to project the normal. So what I need to do is just do this cross product here, maybe. Yeah, because okay, if I take the cross product of the normal and then the up direction, it will give me a direction that excuse me, that points tangent to the wall, which is like what I was wanting originally. So let's see if this makes more sense. Okay, so now it's giving me not a number, or at least it gave me one. Okay, so this makes more sense. So it's telling me to go -7, so that would be to the left, and then +7, which I think is deeper. Okay, let's see. So it's negative and then positive. Yeah, so it was telling me to go into the wall. That's actually opposite of what I would want. So maybe I just need to flip this, but still not moving at all. Oh, well, I'm taking the cross product. Yeah, that's not right. I took cross product with the movement direction, not the normal. Okay, so now it's just telling me to go let's see, +x. Okay, so that would, is that correct? Yeah, that was correct, because yeah, remember our view is isometric, so +x is actually along this wall, but we're not moving. So that could be either because this collider is, or this check collide is not working. Oh, well, you know what? We don't ever add, like, okay, I'm doing this kind of backwards. So yeah, if we collide, then it only adds the fraction, but otherwise we add the full slide length. Okay, there we go. Kind of jumping though. It doesn't look the best. Okay, and also when I move there, it's going the wrong way. Yeah, and also, so this time I'm trying to go into the wall, so I'd expect it to go that way, but it's actually moving me backwards. Okay, so obviously I need to somehow get the input direction to factor into this a little more. Okay, so what do I do? I mean, that's kind of into this project. Probably it has to do with like the left-hand rule and stuff, I think. But it's not like it needs to be flipped because it's sliding in the correct direction when I press right, but not when I press left. Right. Oh, so maybe okay, so left is negative. So maybe I do need to take the absolute value. Put this. Okay, no, it just needs to be like in the same direction as this, maybe. Because yeah, if you project and the vector is in the opposite, like, is facing the opposite way of the slide direction, then it'll be, you know, it'll be facing in the opposite direction. So maybe I need to, you can see if they're parallel by using the dot product. See. And we'll, yeah, so if they're opposite, we'll want to flip the sign. I feel like there's a more elegant way to do this with the math, but so basically if they're pointing in opposite directions, then we'll flip this. Let's see if that actually works. Okay, no, it doesn't work. It gives the same thing. So maybe, yeah, maybe we want to do it like this, so that if the movement direction and the slide direction are opposite, then we'll do that. Okay, I'm surprised about that. Okay, I don't want to spend forever on this. I'm just kind of guessing. Let me see. Slide along while vector project. So normal times the dot product of the input and the normal. Okay, so that's kind of what I'm doing, but okay, so what they're doing, let me think. So I take the dot product and then into the wall. They just multiply by the dot product. And then they... Okay, I don't know what that... Oh, I see. Okay, well, let's try that. Yeah, it's another... So what they're doing is they're scaling the normal based on the dot product between the movement direction, and then they're kind of just subtracting that out of the movement direction to get the part of the vector that's... Yeah, it's kind of the same thing as what I'm doing, because I think... Yeah, it's just basically projecting, but maybe it just works out. The signs work out better. All right. So I guess I'll leave this, but let's just start from the beginning. Okay. So equals the hit info dot normal times dot product, and then the movement direction. So that kind of scales it based on the difference between them. And yeah, I guess then we need to also multiply by the rest of the movement. Which I guess I don't need to do that. It'll just be move length times 1 minus the fraction. So that's the amount of movement that we would go into the wall. Let's see. 3 rest of movement equals okay, and then so that's fine. I don't like to repeat code, so all right. And then okay, I guess I don't float 3 slide movement equals rest of movement minus into the wall. And then yeah, you get slide length is this the length of this vector, and then the slide direction. Oh wait. Okay, so just add it right here, and otherwise we have to clamp it when we collide into the other direction. All right, so let's see if this makes more sense. That's correct. Okay, yeah, so it seems like it's going the right way now. And yeah, that way it doesn't like slide across the wall, it stays in the corner. Okay, so yeah, we didn't need all that stuff with the projection after all. So the only thing I don't like is that it's kind of jerky. I'm not sure what that's about. Will the game be networked or local? Probably just local because, yeah, it's. I think if I wanted to make this multiplayer, it would take a lot more than the month and a half that I have to work on it, or to make it online multiplayer anyway. Although this game would be simple enough that, I mean, I have wanted to try out Unity's new netcode stuff, so maybe we can upgrade it later on, but I just want to get something out simple for the collaboration. So yeah, I guess if we slide, then that means the velocity technically... Oh, I think that... Okay, this is probably the bug. So the velocity technically isn't 0 if we slide. Yeah, so what's happening is we're setting the velocity to 0, and then it has to pick back up again with acceleration, and so that's why we're getting that jerky movement. Unit gives you nightmares at night to this day. You hope they did better. Yeah, I know. When I used to do, well, a couple of years ago on stream, I actually like made a lot of multiplayer stuff, and I ended up like really not even using UNet because it's kind of, I don't know, it wasn't really good for the type of game I was making. So I just used like the low level, well, they called it the transport layer, but I kind of gave up on multiplayer stuff in Unity because when they deprecated it without a replacement, so I haven't even looked at their new system yet. Alright, so anyway, we need to try to figure out what to do with this velocity. So I guess it's kind of the same as the movement. We just take the dot product with the normal and then subtract out the part that hit the wall. Alright, so yeah, this code is starting to get pretty messy, but okay, so float wall dot. So we can just cache this. And then yeah, if we hit the wall and we have to clamp again, then we do know that the velocity is just 0 at this point. Otherwise, we need to just subtract out the part of the velocity that went into the wall, which we can do the same way. So velocity minus equals the hit info dot normal times wall dot times the speed, which is the length of the velocity vector. What's not like about that? Oh yeah, the velocity is a float too. I think I'm just going to change that now because it's causing a lot of issues. Sure, you found that about eNet. You never looked back. Yeah, I know lots of people have started using like eNet, and there's another one that I can't think of that somebody recommended to me. But it seems like a lot of people have made pretty good like multiplayer libraries, so I need to look into that. So anyway, what I want to do is, I guess in this character control, change it to a float 3. And then change this to a float 3. And now we can just use the velocity here. Hopefully I don't miss something else, but I guess if our character starts going up into the sky, then we'll know. And then here I need to change this to be Z instead of X. Oh, excuse me. Oh yeah, and then here it's checking to see if they were set. That's a little cleaner. I should have noticed that when this was starting to get messy, I should have just done a float 3, but anyway. Okay, so now this will subtract out the component that was normal to the wall. So let's see if that smooths it out. Oh yeah, that looks much better. Okay. Alright, so I think we're finally done with basic movement. But let's clean up this function a little bit, how about? And then we can move on to gravity and jumping. Alright, so basically... I think it might be good if we have a separate function to update I guess, basic movement. Okay, and then we'll have another one that can do like gravity and all that stuff. Okay, so can I clean this up at all? I mean, there's some code that's kind of in common, but also we have to handle it a little bit uniquely. Okay, yeah, fortunately, I don't really see an easy way, because I thought maybe we could kind of do a little recursion here, but since we check this collisions differently, it might not be super helpful. Yeah. Because we have to know... Oh, I was thinking that we could move this part that does the length and the direction and then the check collide into its own function, but the problem is we have to know the direction and the length to clip. So let's just leave it at that for now. Okay, so let's make an update gravity. And I like having this in its own function because when the character is jumping, we'll probably turn this off actually. So we'll be able to do that pretty easily by just checking if it's in a jumping state, and if it is, then we can just skip this function. No. See, I guess we'll have gravity. Actually, it'll be simpler if I just hard code it to be only in the Y direction. I don't know why we would change that. Doesn't really make sense for this type of game. Okay. Let's change this to gravity. I don't know, we'll just leave that. And I'll make this a gravity vector. Equals new float 3. So it's 0, then a negative gravity, and 0. And then also, yeah, we'll apply time dot delta time. So I guess this is the gravity velocity. But yeah, it's constant, so we don't have to worry about adding it to the... I guess we could just add it to the actual velocity. Although I don't really want this... It's true. I'm curious. Would this... I wonder like how this code would work if I let it handle velocity or the gravity as well. So it would collide, or so we would raycast downwards. And then actually that'd be fine because if you're, well, I guess we won't really have a ramp. So I mean, but if you were on a ramp, you would slide down it. So I guess we want to, in that case, we might want to add like a friction. Which we might want to have friction anyway. I don't know, but I don't. Let's see. Okay, so this might be simpler than I thought originally. So then we just add the gravity velocity, actually. Okay. Okay, actually, yeah, and I also don't. Okay. So this should actually be like. Okay, so one thing that'll happen here is that, yeah, we need to kind of have this movement velocity be separate because it always tries to move towards this, so that means that the gravity velocity would see, since the velocity in the y direction is 0, it will always just try to remove the velocity at this point, or remove gravity, sorry. Okay, so that means still need this velocity vector, but we kind of have to keep track. Okay, so we just need to extract the part that's in the movement plane, which is pretty easy. Let me think. I'm making a pretty robust character controller here, now that I think about it. So yeah, so we need to extract. Well, I am making sure gravity always points this way, so anyway, move velocity equals basically we just don't want to have the y component. Okay. And then we can move towards that. And then I guess I can add, yeah, it'd be nice to add, I set it back. So velocity equals new flip 3. Okay, I think this will work fine. I don't really like how it's hard coded, so that, I don't know, if for any reason we did add y movement, or movement on the y-axis, or gravity in a different direction, then this would stop working. I don't really know. I mean, it'd be kind of cool to support ramps, but I don't really know if we need it for this particular game. It seems like it is working. It's not, yeah, it's still levitating though, so, oh, probably because I set gravity to 0. So let's, I don't know, normally gravity isn't it in meters, like 9.8, something like that. Okay, so yeah, it seems like, okay, well, doing that broke our slide against walls. Yeah, I think it's best. I'm trying to think of the right way to do this. So we kind of have like movement, momentum, and then we have like, and that's separated from the actual gravity and then our velocity. And then we handle the momentum here. But then also, if we collide, okay, with the bottom, then we'll reset the y velocity as well. Just trying to think of the cleanest way to do it that actually will work well and make the system like robust enough to work in a bunch of different situations. Should I mean, it is kind of nice to have like just a float 3 velocity. Yeah, because when somebody gets hit with a hammer, they're going to need to be flown backwards. So in that instance, the velocity will kind of come ballistic. Okay, so maybe, yeah, we need to have this velocity, and then I need to have a separate float 3, like movement, momentum, and then I guess, so should this velocity, maybe the velocity should be reset every frame, and then we just reconstruct it based on the different types of movement. So yeah, maybe we'll, when it's in ballistic mode, we'll just have to reconstruct the movement moment, or the starting speed from our momentum. Let's change this to gravity acceleration after all. Okay, so anyway. Okay, and then these will just return. So yeah, so now this needs to work with the momentum. All right, and then okay, so let's gravity. Okay, and then we'll need to do a right cast to see if we hit the floor. So technically, we don't really have to do a full capsule cast because we could kind of just, well, I guess not if we're trying to jump on somebody's head. Because I was gonna say we could just do a single ray cast from the center of the capsule, but I think, yeah, I don't think so actually. Okay, so check collide. So the direction we always know is this downwards, and then the actual, and also this vector is also always just in the y direction. So oops, I guess we don't. Yeah, we don't. Doesn't really need to be a float 3 then. So new float 3, 0, -1, 0, and then the length is that. Okay. Yeah, actually we need to do another displacement then. Because yeah, because gravity there is a speed. So yeah, we need to turn it into a distance. Okay, so once again, we just need to clip based on the hit info fraction. And yeah, for now, I don't need to slide based on gravity. Excuse me. Okay, so... Okay, oh yeah, displacement is to float. So all I have to really do is this part. I could just actually just do a times equal the fraction. And then we'll return a new float 3, 0, negative displacement, 0. Okay. So that part we don't actually do right there. Yeah, we'll return the displacement. Okay, so velocity. And then we multiply by the delta time there. Okay, actually, wait, this is yeah, so this isn't velocity, this is just displacement. Okay, so we don't have to do a delta time for that. Why does it work like this? It doesn't know how to add or do the plus equals, I guess. Okay, so I think this is all good. I hope I haven't broken our movement because it was working pretty good. Okay, no, that's still fine. Is it? Okay, so it's levitating though. Oh, but I think yeah, I changed the name of the gravity, so I just gotta put back in 9.8. Okay. Oh. What happened there? Oh, I think, yeah, there's probably, you can slide through this crack right there. So I just need to make sure that you can't reach the edge of the platform. Okay. Okay. This didn't happen before. Why is it just now starting because of gravity? That's also wrong. I was just moving straight into it and it's not behaving. Okay, so why is, yeah, it's starting to go backwards again. So what, did I change anything here? I don't think so. And we still, so the movement momentum, again, it's only in the two, I guess only in the X and Z plane because this input move is always 0 in the Y direction. So technically this should still be exactly the same as before. I'll take out all the stuff with sliding. I guess the movement momentum will need to be 0. well, it's kind of jiggling back and forth. Okay. So let's move this back, but then take away gravity and see if for some reason the gravity is messing things up. Okay, well, it's going much slower when it slides now. Oh, well, it's because I set that to 0 right there. Okay, well, I'm not liking the implication here because now I think that this, when I turn gravity on, the capsule is touching the ground, so maybe the movement is like brushing up against the ground and it's seeing that as a collision. And so maybe that must be what's affecting these raycasts, because it's working correctly without gravity, but when I turn gravity back on, some of the movement gets incorrect. Yeah, like for some reason it goes backwards when it's touching the ground, but only on the left wall. And then I can also go through walls. And I think it's just because the hit direction or the hit normal just must be incorrect or something. Oh, now I can't get it. Oh, there it goes. Let me back through. Okay, So what I would normally do is I would just not raycast from the bottom, but since we're using the capsule collider, I guess I can move the capsule collider up a little bit. I mean, yeah, I guess that would work. So we would just move this top point up slightly. Okay, but we can't do that. Oh yeah, we can't do that for ground collisions. So I need to make another function or let you be able to specify it. Okay. Let's do check move collide, and then I'll have a separate check ground collide, I guess. Okay, so here we'll just move the bottom point up a little bit. So move bottom offset. Okay, and yeah, so I'm going to need another function that's basically the same. But I guess we can just extract this part. Oops. Okay, now it's not wanting to do it. Can't you... Okay, whatever. Private void, capsule cast. Okay, so float 3, top point, float 3, bottom point. Oh yeah, I'm gonna do this. It's this raycast debug is gonna be incorrect too, but oh, and yeah, this should return a boolean actually. Oh, okay. I called it length, not distance. Oh, and I need the mask as well. Okay, so let's just change this to include the top point and the bottom point. Okay. Top point, bottom point. Oh yeah, we don't need the height anymore. Okay, and I was going to complain that the character hint info is not initialized, so I just need to create it right there. Okay, so now finally we will return capsule cast, top point, bottom point. Oh yeah, I guess I don't really have to pass the radius here. Direction, length. Okay, and I probably shouldn't even have the effective length in here, maybe. I don't know. Yeah, because we don't offset that like that. Okay, so let's move this out. And then we'll pass the effective length into here. Although now this fraction value is going to be messed up. Oh. What's it complaining about? Oh, I don't pass. Yeah, or I don't get the hit info. Oh yeah, I don't know the Unity hit info. Although I guess technically this will just be... I don't know, this is getting kind of hacky and convoluted. Okay, the whole reason I'm trying to do this is because I want to have another version of this that just does... I want to have another version for gravity, but now I even forget what was I trying to change in here. Oh yeah, because the gravity version, we don't want to have this offset right there. So really the only problem is I just need to add this. Okay. So this is slightly less efficient, but we'll live, I think. Okay. So this is fine. And now we can just return. Okay, and now yeah, we want another version for gravity. Okay, and the direction is obvious on this one. Although I'm just thinking ahead to when we do ballistic movement, it might not be obvious, but yeah, I think in that case, we're gonna have to treat the Y collisions and then the movement collisions separately anyway, so. And yeah, then I can remove that. Okay, so hopefully this will fix the problem. Okay. Oh, well, I still have it set to 0, actually, don't I? Okay, so yeah, that was the problem, I think. Here now with the offset, the bottom casts. So unfortunately, they don't exactly match our collider because we've shrunk the bottom up a little bit. But I think it should be fine. I'm just... technically, if we had like a really short step, you'd be able to move through it, but we're not really going to have that in this game. Okay. As you can see, making character controllers can get really complicated, so... Alright, so what else? I guess jumping is next? Okay, now jumping, I think is where this is going to get complicated. Let's, So we'll want to have like a start, I guess a Boolean, a jump input. And then on the character engine, we want to know like when the jump starts, and then also when the character lets go of the jump. And there's all different kinds of ways that you can deal with it to try to make jumping feel better. I'm not sure. How does it... Do they jump enough here for us to really get a good look at how it works? Okay, well, Mario's jumping. So it seems like that you keep your same velocity when you're jumping. He doesn't ever try to do like a mid-air change in direction, so I wonder if you just can't. well, there he moved, but it was when he bounced on somebody's head. So it seems like, yeah, I don't actually, it looks like you can't change your jump direction after you've started jumping, which normally doesn't feel very good. But that seems like how it works in this game. Probably should try to find some better footage of it, but yeah, I don't know if I want to really. Yeah, I don't think we have to recreate it perfectly. that kind of control doesn't usually feel very good, so I don't think I want to recreate it. Because usually, like at the top of the jump, usually you should be able to kind of like change your movement. So, but anyway, let's I guess first let's just get the jump working correctly. So we'll make another private float 3 update jump. And we'll have okay, so the jump speed, yeah, will actually be a float 3. And I guess then it's a velocity, not speed, but I'll just call it momentum. And then we'll need we need a state variable for that, what stage of jumping. So I guess grounded, and then rising, and then falling, I guess. Okay, so here now okay, let's see. So yeah, if jump state is grounded and then they press the jump button, then we actually want to start jumping. And there's some other, usually, yeah, it feels good also if you like start the jump when they're grounded, if they pressed a little, like a split second before they became grounded as well. But so right now we don't really have the concept of if the character controller is grounded or not, which would mean they're touching the ground. Okay, so here we need this to not only return like the gravity displacement, but also let's see. It's probably better if I have something that will tell me if we're grounded at the very beginning, because then if I know we're touching the ground, there's no reason to update gravity. And then also the jump will know. if we can start a jump or not. So let's see that. Private bool update ground state, or I guess check. Okay, so now we'll need to do a collision. Yeah, so I guess it's the same as this, but we just like check a small value to see if it's grounded or not. We don't care about the hit info. Okay, so that's fine. Grounded equals check ground state, and then we can pass that. So if we're ground, or if we're not grounded, then we'll update gravity. Oh, this should be a Boolean. Okay, and then we'll also update jump, and then we'll pass in this grounded state. Okay. So I'm trying to think of, let's see. Yeah, so we want to start the jump right when this jump input goes from being false to true. Or if that happened like a split second before we became grounded. So in that case, we need to keep track of the last jump state as well as float. Drop trigger. Yeah, so this would be the last time that the jump key was triggered, which means it was false and becomes true. All right, so let's see. So if last jump state is false and then now it's true, then we need to store this value. Okay, and okay, so bool, we want to start jump. All right, let's see. So bool jump input triggered. I guess this is this value. Okay, so this is true if that or the jump trigger time is currently less than or equal to a certain time in the future. Let's see. So I think the easiest way to do that. So jump, leeway, period. So I guess we could just add it. Let's rename that. So if this timer is less than or equal, or if the current time is less than or equal than this timer, seconds, simplify that. Okay, so yeah, if the jump is grounded, which means we're not currently jumping, and then we want to start a jump, then we'll currently jump. Equals rising. And then if jump state equals rising, then we'll return, I guess, the jump speed. Turn new float 3 0 jump speed 0, and this will, okay, and then also if jump state is rising and input, or wait, control jump input is false, then we want to set the jump state to falling. It will return 0 otherwise. And then falling. So update jump actually should happen first. And then if grounded is false and jump state does not equal rising, then we'll update gravity. Okay, so how do we change from falling back to grounded? So I guess that happens if jump state is falling. Okay, this can actually happen on the same frame actually. So if jump state is falling and we're grounded, then we set this to grounded. Okay, and this is important, yeah, because we don't want to jump again until we've touched the ground at least once. So, all right, so let's, oh, well, nothing's going to happen yet because well, first of all, I didn't set those new variables, and also I haven't updated the character control input to set jump input at all. So ground check link. Okay, I just realized something. So if I set the ground check length to basically anything, and I keep update gravity from running at that point, then it's going to hover above the ground by a little bit. So probably the best thing to do is just take that away. Technically, we're going to be doing an extra capsule cast that we don't have to, but I don't know, if we need to optimize later, we can deal with it then. Okay, so leeway period, pretty small. And then jump speed, let's just set it to 1 for now. Okay, and then back here in the character control, or input controller. So if keyboard current, I guess space key will do it for now, is press. Oh, I can actually do this even simpler. So control dot jump input equals that. Okay. Oh, okay, so it... Okay, I don't know why it's bouncing. So I think the reason that it's going so high is probably because I forgot to scale by time. Yeah, so I just added the speed here. Technically, yeah, I'm not even doing acceleration at the moment, but... Okay, yeah, so now it's too slow, but at least it sort of works. It's one happy capsule, yeah. But at least jumping works, and when I jump up against the wall, it doesn't seem to mess up the movement, which I'm happy to see. Okay, I wonder, we'll probably start getting weird stuff again if we hit the ceiling. Oh, what happened there? Yeah, I don't know. Capsule cast. It seems fine at first, but I feel like, yeah, we're gonna have the same problem if you jump up against the ceiling and then try to slide against the wall. I think it's going to do the same thing that happened when we didn't test the bottom of the capsule. I'm kind of surprised something weird doesn't happen when I'm right up against the wall and then I fall, because then I thought maybe one of the sides would, okay, there we go. Yeah, so I'm not pressing anything and it's sticking to the wall. So I guess we could fix that by bringing in the radius of the capsule. I know, I feel like I've said this a million times, but I just feel like it might be easier just to do raycasts, but to have more control over how stuff is working. But basically, okay, so I'll need to... I mean, I guess the good thing is that if I do ever have to switch, all this logic is encapsulated in this specific class, so it won't be that difficult to change. Right. Okay, so this will be gravity, radius, and set. And then I guess for here, maybe I should also, yeah, scoot in the pop a little bit. So, okay, I think this will be fine. I mean, I don't know why. I don't think you'd ever hit the ceiling, so I probably don't really need to worry about that. Although I guess you could jump up and another character could land on top of you, but anyway. So this can be very small, I think. Let's see if I can get it to stick to the wall again. Hopefully not. Probably easier if I made the jump speed a little bit faster. Okay, so it seems like I fixed that. Alright. Okay, so... Okay, so I think what's happening here is, yeah, I actually forgot to fix this. When the gravity... Or do I fix it? Character engine. So yeah, when gravity... Yeah, gravity should reset when it collides here, and we should also reset gravity when we start falling. Yeah, just in case there's anything left over. That way the acceleration will start from the top. Yeah, it's going to be pretty floaty though, so I think the gravity value needs to be higher, but... This capsule, yeah, it's 2 meters high. Why did it just... Oh, it's because I... So that's about... I don't know. I don't know how tall Mario is. Probably not quite that tall, but... Yeah, it seems really floaty, so let's increase the gravity. And the good thing about our system is changing the gravity doesn't actually affect the jump, just the falling bit. Okay, it still feels kind of floaty. Also, did it just bounce? Okay, well, yeah, I can kind of tap the space bar to get it to bounce. I was like, I thought it just bounced on its own, and I was like, I don't know, I haven't done any physics like that. Seems like it does sometimes, actually. But maybe it's just my imagination. Okay. So obviously, yeah, the jumping physics still aren't very good. The main problem is we want the speed to be a lot higher when it starts, but then kind of slow. And then also, you have too much control when you're in the air. Okay, now it is this kind of jumping on its own. I'm not pressing anything. Let's look. If I turn on debug. Okay, so gravity. Okay, so that's the keeps on changing between all these jumps. All the different jump states you can see. Maybe I've done the timer incorrect. So the delta time. Oh yeah, this shouldn't be. Oh, see, I'm adding delta time. This should be just the time variable. Okay. Yeah, so basically the character was continually jumping. Yeah, so now it's grounded and I can press rising, falling. Okay. Is my... Oh yeah, okay. I was afraid that my webcam was in the way, but no. Okay, so that seems to be fine. So what we want to do is when it starts jumping, we'll add the current movement momentum into the jump momentum. And then when you get to the top of the jump, you can kind of adjust. But actually, yeah, we shouldn't do that yet until we get the, I think, the jump arc to work, okay? It needs to have like a boost when you first start it. Yeah, starting to look good. I think so too. I think once we get a nice character controller, that's going to be the hardest part for sure. Well, maybe AI. Although I think AI will be pretty simple actually. We'll just basically, it will just run to you, try to hit you, and then stop and then stop for a bit and to let you run away and then try to get you again. They did say you don't have to do AI for the collaboration, but I kind of like to. Okay, so anyway, we need this jump speed. It needs to have some acceleration and it needs to start really quickly. Oh yeah, I don't even use this jump momentum, so... Yeah, so when it starts, we'll basically add a lot of momentum right away. So let's change this to like jump, rise, speed. Yeah, I don't think it has an A. And then we'll have jump, initial momentum. And I'm not going to worry about adding in the X and Z momentum yet. So yeah, when we first start the jump, we'll change jump momentum to new, float 0, initial jump momentum 0. How funny would it be if you theme the map around all the projects you've done on my YouTube channel? Oh, that's actually a really good idea. Grass outlines, candy cane in the back. That would be pretty fun. I'm kind of tired of working on grass, but I guess I could just plug in one of the ones I've already done. What's it complaining about? Oh, yeah, this should just be jump momentum. Okay, and so then we'll add this rise speed to the momentum every frame while we're rising. Plus equals, and then we'll okay, yeah, then we return jump momentum times time delta time. So this is jump rise speed. I guess it needs to be acceleration so it can be frame independent. Oh, yeah, frame independent, that's the right thing. Doesn't need to be fancy. That's true. I guess I could even do my little grass lawn shader. Yeah, I haven't really thought too much about how this game will look yet, which I guess probably once I get a good character controller, that will be the next thing, because I really hate working with this placeholder art. It kills my motivation a lot of times. So that's a cool idea to do like toon shaders. I like penguins and little birds and stuff, so maybe we'll do that kind of theme. Yeah, the collaboration, they were thinking about having like a standard character people could use, but I haven't really heard much about that, so I don't know if that's still on. Let's just start it with that, and then the initial momentum. Don't really know what these values should be. Okay, well, it's not too bad, but it's still too floaty, I think. Although the original game was pretty floaty, like I said, I don't think I'm gonna copy the physics because there a lot of Nintendo 64 games. I mean, I love them, but a lot of them didn't feel the best to play. Okay, so, and I'm gonna increase the gravity again. Okay, well, now I think it's too sensitive, but I think the gravity is starting to get there. One problem is that, okay, so probably what I should do is when we start falling, I should change, or I should set the gravity to start off with our jump momentum. .y. So that way it won't just like hit the top and then like a pyramid, it'll be more smooth. Okay, well, yeah, it's too sensitive. Let's bring this down a bit. I'm gonna set the gravity really low because I kind of just want to see if it smooths correctly. Okay, so that's Because the gravity acceleration is 1, so I feel like that's too fast. Is there some bug with that? Okay, yeah, so whatever I change this acceleration to, it doesn't seem to affect it. Why is that? Okay, well, the gravity... Okay, so I guess I need to... Yeah, I need to... The problem was the gravity is just a float, so it doesn't have... like directionality to it, so I have to... Yeah, when I was starting it out moving downwards, so I just need to invert that, I think. That's kind of confusing. Maybe I should change the way that works. Okay. So okay. So I just press play. I'm not even jumping, and it starts me off. Oh, you know what? I bet that the game probably starts jumping immediately because this jump timer is set to excuse me, is set to 0. So when I start, I probably should set this to a small number. I'll just do negative the leeway period, like -1 or something. Still, it keeps rising forever. Which is weird because I didn't change the gravity calculation. All I did was make it start negative. Oh. Okay, so yeah, I know what I've done. I've set the... Oh, wait, that's correct. Yeah, I thought I was setting gravity acceleration, but no, I'm setting the actual gravity. It should be okay. Let's watch. Okay, so... Okay, no, it is working. Okay, the gravity is just so slow that looks like it's going up forever. Okay, that was kind of... I should have realized that, but... Okay, so now we finally have a smooth arc. Okay, yeah, there we go. That's much better. Now, right now we can jump forever. So probably we need to have like a maximum time that you can hold the jump button. So we should also have a jump timer. And then an initial jump or a jump hold period. Okay, so when we start jumping, which is right here, then the jump timer or end timer will set this to the current time. Not do that again, and then jump hold period. It's a nice jump right there. Well, thank you, Skylar. We're just getting started, and it's gonna get more complicated. So hopefully I can keep it looking good. Okay, so then we want to stop this if jump input is false or the current time becomes greater than the end period. So let's say we can hold it for a second. And this is so we can have short jumps and then also longer jumps. Okay, well it did stop. Although I'm just holding it, I haven't let go, and it's letting me continue to jump. And I don't want that to happen. It shouldn't jump again unless I release the jump button. So let's watch and see what happens. So we have the jump. Okay, so the leeway timer is continually increasing. Oh, it's because I'm not setting this last jump state at all. So last jump state, it needs to match the jump input. Because we need to watch, again, when this changes value. Okay, so now it stays at that point, and when I'm still holding the space bar, so now I can release it and press it again, and it'll let me jump. So what's the shortest I can do? I actually think that still is a bit too high. You should be able to do shorter hops, probably. So I guess we'll need to make the initial momentum smaller. And then also this hold period I think is way too long. So let's do it something like a quarter second. Okay, that looks a bit better. So that's just tapping the space bar. And then if I hold it, you can jump higher. Probably that's too small though. Although I guess yeah, we can change this as we need to balance. I feel like, I don't know, it's probably okay. I was gonna say, I feel like the jump maybe is a little bit too weak now, because it seems, I don't know. You can play with it forever, I guess, but it just seems like it doesn't rise fast enough. Okay, that feels a little better, I think. Looks like the type of thing you tune when you'll have your character models. I think you're right, because yeah, we need to just make sure you can jump on top of the character that's dressed as Bowser or whatever we plan to do. It doesn't really yeah, working on it or worrying about it too much is probably a waste of time. But I just wanted to make sure that I could get it to feel good. I think I'm pretty happy with that. Alright, so what next? We've got jumping. Okay, we need to do yeah, the horizontal movement while we're jumping. Speaking about the horizontal movement, I need to add a little bit more acceleration to it. Yeah, or yeah, because it was pretty much instant because I had it at 1,000 acceleration. Okay, yeah, that does feel better. Okay, so like I said, right now when you jump, you can basically, you have full control, which, I mean, it can feel good, but I think it's a little bit too much. So, when we're, how do I want to handle it? Like I said, usually it feels good if you can change the movement a little bit when you're near the, like the apex or the highest point of the jump. So I guess that'd be right. So it'd be right after we enter in the falling state, probably. So probably what we'll want to do, yeah, so we'll want to add in the current move momentum into the jump momentum. So let's feel how this looks, and then I'll set it so if jump state is not equal jump state grounded, then we just can't move for now. Okay, so And then we'll set movement momentum to 0. And then when we land again, okay. Yeah, so sometime when we land, we want to set the movement momentum back. Although I guess we're technically not going to change it for now. So this... Oh, also, I can't do this because, yeah, because it's not going to collide. If I do this, you'll be able to jump through walls, I think. Let's just try it, but... Okay, well, yeah, now I can't even move. Or I can't move unless I'm jumping, which is not what I wanted. But yeah, you can move through walls, so... That's just because we add the movement momentum to the jump momentum, but we don't actually raycast. So... You know, now that I think about it, I don't do any raycast for jumping, so technically you can jump through the bottom of whatever. That makes me think, should I, maybe I should move the ray casting outside of all these functions, and we'll just take the calculated displacement and then do ray casts with that. So that way I won't have to worry about ray casting for each specific type of movement. I guess the problem is... Well, no, we can just make it like we're already gonna have to raycast separately for the Y direction and X and Z. So I was just thinking like, well, what about sliding? Like, do I only want it to work from this movement? Oh, the other issue... how do I want to... Yeah, the other issue is that this movement momentum won't update based on the collisions. Okay, I'm trying to... This is a design issue that I've run into a couple times. Mostly it's... So I need to kind of have a separate momentum for like this move towards, but at the same time having it separate than the other displacements makes it so it's difficult to keep up to date with collisions. Maybe... What? I tried to do this before where I just had a single velocity and then we just did this move towards with the X and Z. I think... Why did I move away from that? I guess I just felt... I mean, that was only a couple hours ago, but I guess I just felt that I didn't like that we just zeroed the Y component, because that's kind of assuming. But... Oh, and also because I need to do like a move towards. So maybe a better way, instead of doing move towards, is we just like kind of calculate like the yeah, we just don't use move towards, we just calculate like a change in this momentum to bring it towards our max speed. Well, I don't know, that's not different, but just a... I mean, we might still use the same function, but just a different way of me thinking about it. Sorry, I don't know if my rambling is making sense, but... Okay, so... But yeah, I think it's gonna... This is going to start getting really spaghetti code-ish. I think if I had to do a raycast in here. So it'd be better if I move all of the collision raycasts outside and just do based on this displacement, I think. So what would that look like? Check. collisions. So basically we'd have this code and the gravity code. Alright, so displacement xz displacement x. Yeah, because I want to test separately on the x and z plane and then the y plane, or not y plane, y direction. Okay, what's it complaining about? Oh yeah, we calculate, or we use this variable name somewhere else. So the length. Um, okay, and then gravity is a bit simpler. So this is the displacement dot y. Oops. Okay, and now I should just make this point upwards, and then gravity will be negative. Oh. Okay, yeah, it doesn't like using this here and then again here. I mean, I could fix it, but I can also just enclose it in a block. Okay, so, but then I want to get rid of these momentum variables, probably. Yeah, so it'd be better if I just have a single momentum for everything, which I know I switched from earlier, but I think this will just, I think it'll just make everything be more organic. Everything will just kind of work. All the systems will work with one another, and I don't have to worry about, like, here it was already starting to get confusing because I like had to set the gravity variable and then had to set then try to get jump and movement momentum to synchronize. So if everything is just in a single class or single variable, it'll all happen at the same time. The only problem is basically extracting this input from it. But so anyway, so yeah, if we collide here, that and okay, and then we can just set displacement dot, we'll just merge the clipped displacement back into here. And then, oh, I just messed everything up because this should have been, yeah. I'm gonna remove all that stuff I just did so I don't. Yeah, so what I copied with displacement should have actually been the velocity. Yeah, so here we set velocity to 0, or momentum. Okay. Okay, yeah, and then we can set just the momentums to 0 there. Okay, so I think hopefully this code will still work. So yeah, we'll check. Yeah, I don't really need to return that, I just need to return the displacement. Or a modified displacement. Which I guess I could just use a reference keyword. Okay. So this update movement, basically all we'll do is based on the momentum. So we want to move the momentum towards our input, but only on the X and Z. So basically we do the same thing I did earlier. Why did I why did I switch from this? I don't know. I guess I thought it would be easier if they were all separate, but I don't know. Working on jump shows how that's kind of not the right way to think of it. So then momentum. And I guess I don't really even need to return a displacement because everything is inside this momentum variable, right? I wonder if I'm gonna regret this update, but okay. So momentum dot x or dot y, then we subtract gravity from it. And yeah, I think that's it for this. Okay, so now for jump, we just immediately start jumping upwards. And it already has the movement momentum inside of it already. And then so now we don't have to set that because it's already stored in the momentum variable. Okay, and yeah, then we want to rise this. Okay, so hopefully I didn't break anything doing this refactoring. Okay, what's it look like? Oh yeah, I don't need to do that. Okay, so it just disappeared. Oh, it's going through the ground really fast. Do I zero out? Yeah, I do zero out when we hit the ground. So I want to see if I can tell what's going on. So momentum right now is negative 2.56. Okay, so it seems like it just falls through the ground. Well, obviously. So that would mean this part isn't working, I guess. Let's turn off, I'm going to turn off gravity and jumping for now, and we'll just see if the basic movement can work. Okay, so I'm pressing the keys and nothing's happening. Does the... Okay, so the input move at least is going. But yeah, we're seeing that momentum is 0 here. Oh, well this is not right. Okay, well yeah, well, I think I'll just remove this if statement because it was incorrect anyway. Yeah, that's why, yeah, I forgot we could only move when we were jumping before, and that's why. Okay, so thankfully I didn't break all that collision detection we did earlier. So it still works. I bet it, probably... Okay, I was gonna say, I was gonna say, I did change the way that the gravity works, because now we... raycast upwards, but if the length is negative, it should... Oh wait, no, actually that's true. This, we need to pass in the correct direction here. Alright, so we, float, gravity, length, or move length equals absolute displacement dot y, and then float 3 move direction equals 0. Okay, so technically this won't work if yeah, if this displacement.y is 0, but I don't think that will ever happen. Okay, and then yeah, for this ground state, we'll always want to raycast downwards because we want to check if our feet are touching the ground. Oh, I didn't turn back on gravity. Okay. Fortunately, it still goes through the ground. Oh, yeah. I was taking the absolute value of the movement length, which we just... Or I was taking the sign of the movement length, which we just passed through absolute value, so that's always going to be positive. There we go. So can I jump again? Okay, so everything seems to work fine. Yeah, it looks about the same as before, but I think that the code base is going to be more prepared to do some more advanced physics now. We could clean this function up probably. It's kind of messy. I'm going to hide it. But let's not worry about that for now. Okay, so we want to slow down this movement when we're jumping. Okay, so usually, like I said before, usually you can kind of jump or change your direction when you're at the top of the jump. So let's see. So I guess that would be, so we're at the apex like when the momentum.y is negative, but we're in the falling state. Serialized field, private float, jump, direction, adjustment, after apex, period. So this will be like a timer or period after we reach the top of the jump where we can, we'll be able to change our movement a little bit more. So yeah, we'll have another timer here. So jump, apex, adjustment timer. Okay, so we can check if we're at the apex. So if jump state, if we're falling, and okay, I'm gonna need another state variable because I'm gonna have to check like if the momentum was I guess I'll have to do that and update gravity actually. Okay, let's do it in movement. So if jump state equals falling and momentum.y is less than or equal to 0, and then we need another state variable to say that this is the first frame that's happened. Private boolean last before jump apex. I think it'll be easier if I say like last falling. Yeah. Or actually, yeah, I think so. I keep switching, but last rising is probably better. Okay, so then we'll set the jump apex adjustment timer to time.time plus that period, whatever I called it. And then last rising equals momentum.y is greater than 0. Okay, so that takes care of all that. So now we'll need, basically I need to adjust this max speed. So float speed adjustment equals max speed. But if we're not grounded, but we're in the falling state. Okay, so what? Let me think. Jump speed multiplier. Okay, so if jump state does not equal grounded, and so basically, yeah, Okay, so we want to be able to go at max speed if the jump state is grounded or jump state is falling, but momentum is either rising or this timer is, or time is less than this timer value. So if jump state equals grounded, maybe we should just test this first, actually. Okay. Yeah, we can just like kind of watch what these variables do to make sure that they actually make sense. Okay, so have this jump speed multiplier. So while we're jumping, we'll want the speed to be much slower. And then this, so I don't know, for like a quarter second or something, you can adjust the speed. That's not a quarter second, but okay, so I'm able to move the speed completely. Oh, that's because I don't, yeah, I don't actually use this variable. Okay, otherwise, the speed is max speed times the jump speed multiplier. Okay, that doesn't feel great. Okay, so the problem is here is I want it to actually keep your momentum, but you just can't change it. So I need to change how I do this. Let's see. So okay, so I guess I don't really change the max speed. I would, yeah, because this, so we always like want to move towards this max speed. It's just the acceleration changes. So yeah, do Excel. I could also format this better, I know. Yeah, don't have to worry about the delta time probably. And let's move this to max speed. So, okay, so we're always trying to move towards the max speed. It's just the acceleration goes, we can't change it as much when we're jumping. So I should change this to speed or Excel. Okay, yeah, that felt pretty good. So right when I start jumping, I'm going to try to move backwards. Yeah, you can kind of control it. So basically, it usually feels good in platformers if you have like a little burst at the top of the jump where you can have better control over the move direction. So that's what I'm going to try to implement. I have a few more minutes for the stream, so hopefully I can finish it up. So we have full movement if we're grounded. Let's actually break this into a different function. So private bool jump, or let's do is full acceleration. So it's full acceleration. So if let's do, I guess we can do a switch. Jump state. So if we're in the grounded jump state, then we'll return true. If we're in the rising jump state will return false. And then if we're in the falling jump state, we return where that we're either rising to the top or it's just after this apex period. So yeah, I don't know if this will feel correct, but we'll just try it out. So if greater than 0 or time is less than this jump adjustment timer. Oh yeah, now it's gonna worry about default. Okay, let's false, and I'll just take this up. Okay, so let's see how this works. Alright, so that was me just holding the same direction, and now when I start the jump, I'm gonna flip. Okay, and you can see when you... Actually, it worked pretty well. Yeah, so when you get to the top of the jump, you can change your direction or a little bit better. Having trouble talking and pressing all these buttons, but it actually might be a little bit too strong. But I don't know. That's something we could play with. Let's so jump Excel multiplier and then jump. Alright, let's just call this the apex Excel multiplier, and that way we can kind of have a little bit more control over that. So when we're grounded, we can just give it, let's see, let's change this to get Excel multiplier. So grounded 1, falling, the apex, and then otherwise it's the jump acceleration. I should probably, I think it'll make more sense if it's arranged like that. So now acceleration can just be movement acceleration times get multiplier. Okay. Oh, yeah, that was set to 0. So let's just make it like, I don't know, 0.7. So not quite as much as if you're on the ground, but you'll be able to adjust. Yeah, that feels pretty good, I think. Yeah, this is where using a controller is a lot easier, I think, but speaking about controller, is there anything I've done that would not let a controller work? I think yeah, just this input move can use a control stick. Yeah, so it's, I think, fine so far. It would be cool to add gamepad support. Okay, so I guess next up we need to do what happens when we collide with another player, probably. So, because when we jump on their head, you'll want to like do another jump, and then the player that was jumping will also get stunned. And then, of course, like I said before, we'll have like we'll need to do like ballistic movement when you get knocked with a hammer. Does this not work? Yeah, it's saying that this isn't ever used. Oh yeah. Okay. So okay, that's kind of, I wasn't even. Yeah, so if we're falling, then we need to check. I guess I deleted it because I thought we had it worked out a second ago. Yeah, so if momentum is greater or time is less than this timer. Otherwise, we'll just return the this again. All right, let me make sure that still works because I deleted some code there apparently. Okay, so it's still fine. Okay, so I'm pretty happy with the way this character controller is turning out. I think, like I said, well, next time will be the real fun part because, like I said, we're going to have to try to work on interactions between characters. So I'm a little I'm worried about how that will go. Mostly because, like, when one character collides with another one, you need to try to decide, like, who sends the events out because you don't want to get duplicates. Yeah, so I'll have to be careful about that. It might be better. Well, we'll see. One way you can do that is kind of have like a separate collision cache that gets like notified for all collisions in the frame and then sends out events to everything. That's probably the best way to do it because it can filter out duplicate collisions. Even though it's going to be a bit more work, I think I'm going to appreciate it in the long run. But I think, yeah, that's all for me for today. I guess this week. So thanks everybody for coming by and chatting. I hope you all have a great weekend. Thanks NTT. I'm pretty happy with what we've done so far. But yeah, we'll continue working on this Monday. So I'm live Monday, Wednesday, and Friday at 9 Eastern time. I also have my YouTube channel if you want to check out various game development tutorials. I'll put links to stuff in the chat if you're new and you liked what you saw. I'd appreciate a follow or anything if you feel like it. But yeah, I hope you all have a great weekend and I'll see you Monday. Bye-bye. Oh, and happy 4th if you're from America. Bye.